IPython is one of the more robust shells out there, and then the combination of Emacs and IPython that works through IPython 1.21, but does not yet work with the current stable release, which is 2.0. And so, you know, I'm going to try and not take too much of your time, but hopefully introduce you to a couple of interesting tools. Okay, so for Unix-like system, uses the direct operation of the computer by entering commands as text for a command line interpreter to execute. And you create scripts, and they execute one or more such commands. So this was the original way that, or this is the way that most of us deal with the actual operating system. But it's also been extended in these domain-specific languages like R, and for a whole genre of exploratory data analysis. So it has become, it's certainly a very important part of my workflow. So I wanted to share it with you because I think it adds value across the board.
Can I ask a question?
Sure.
So this looks really like a really cool text manager. What is this called?
This is org mode.
Okay.
I'm so glad that at this moment we are prepared to like see your life be changed in a matter.
This is not actually thoughtbot shells. It's actually.
But to be fair, org mode will change your life.
Okay.
I was asking that.
So, okay. So the default REPL or shell that most of us on Linux use was actually originally developed by Stephen Bourne at AT&T. It introduced the concept of piping, here documents, command substitution, variables, control structures for conditional testing, and looping and file name wildcarding. And it was influenced by Algol 68. And parallel to that, around the same time, we're talking about 1975 to 1978, Bill Joy was at Berkeley, and he was developing the C shell, which took its influence generally from C. That's where the tilde notation came from, the change directory path, job control, path hashing, and all of the things that we're used to now. Okay. So the shell itself is an interactive command language as well as a scripting programming language. And it's used by the operating system to control the execution of resources in the operating system. Shells are created for other operating systems other than Unix. There's the PowerShell in Windows. Mac uses also the born-again shell. And your GUI, in many ways, is just a visual shell. So in Linux, our GUIs vary, but GNOME, KDE, XFCE can be thought of visual or graphical shells. They're asking for resources, starting applications, killing applications. They're doing it through a graphical user interface, but it's the same basic process. And if you want to stay up on the gossip, the initialization of Linux itself and the kernel is now, many years after its origination, being replaced with systemd rather than the init shells. So, and that's caused some controversy over some bugs. But that's a little far afield of what we're doing here. So. And then there are a list of, a variety of shells: the Bourne shell, the Almquist shell, the Born Again shell, which is standard in Debian and Ubuntu, the Korn shell, which was written by David Korn, which was I think the first POSIX standard shell, the Z shell, and then there are a whole bunch of C shell compatibles. The C shell the 10x C shell, the Hamilton C shell, which was in OS2. And now, none of these shells were particularly robust in terms of control function or being forgiving. So as scripting languages developed more and more, each of these sort of in turn took a crack at a shell. Python derives from Perl. Perl had its own shell. There's the Py shell, and now the IPython shell. And so, and one of the other shells, of course, that came up, that was developed, was the Emacs E shell, which is enormously useful if you're going through the hell of actually compiling or trying to get something to work that you never have, and you're getting these long error messages, right? You can always pipe your error messages into a file and then open them in Emacs, but it's also convenient to just try something out and be able to clip and save error messages, to be able to search through it with all of the capabilities that we've come to use in Emacs. So in the E shell itself, in Emacs, has its own manual, and in it, any tool you use often deserves the time spent learning to master it. So whether that's whether that claim is true is certainly contestable, but for most of us with Emacs, it's certainly been worth our time. All right. So the drawback of the E shell, and I have to confess, I'm not exactly sure why, but if you're setting up some rather complicated programs on Debian or Ubuntu, the E shell doesn't actually allow Debian to configure them completely. So if you try to install Postgres or PostGIS or QGIS or those in particular, if you try to do that in the E shell rather than in a born-again shell, it won't fully finish configuring. And then the other derivative of sort of shells and REPLs are the consoles. And one way in which many people come to Emacs is through Emacs Speak Statistics. So the R console is simply a REPL that executes R commands one by one. And Emacs Speak Statistics makes that process much, much easier. So, in their documentation, they say the rationale for developing Emacs Speak Statistics is that although GUIs are developed for each of these statistical packages, they tend to be more limited than the underlying language themselves. And anyone who actually has to push that language to its bound has to wind up using the language itself, and the editors embedded in those statistical packages, those statistical domain languages, are inevitably worse than Emacs. They're more limited. They don't allow you to do what you want. So why not, since you're basically running a sub-process, why not edit in what you already know and save the time of learning all of this inferior nonsense with these domain-specific editors? So that was how I came to Emacs, because I wanted to do that with R. But there are many people who do that for SAS or SPSS or other stuff. And I guess the best shell that I've seen for any of the scripting languages is IPython. And IPython allows you, so in R, you're executing sort of one line at a time, or you can execute a loop and a couple of things. But in IPython, they expanded on the notion of, instead of having a line that you were executing, you have a cell. The first place that I ever saw this, although I don't know that it's the first place it was ever done, was in the MATLAB notebooks, which some of you may have had exposure to. But MATLAB had these cells that you could do. Well, you know, MATLAB license is $2,500. You know, for some of you that work at private companies, that's nothing. But, you know, if you're a poor student, right, you don't want to be spending $2,500 every time you turn around. So having this in Python was pretty amazing. How does IPython work? Well, you start the IPython notebook in the directory that you care about, and it starts the Python kernel, and it starts a web protocol, and because it's a web protocol, it communicates over a port. Emacs, because it can, you know, it has support for things like tramp mode, can read from that port. In this case, it's port 888, right? And so you're effectively having a tramp session with yourself. So you can send things back and forth and receive from the kernel. And so Tafuki Arakami, who wrote the Emacs IPython notebook, took advantage of that and was able to get the best part of IPython and preserve Emacs editing capabilities rather than having to edit in the browser. So I just wanted to show you quickly a little bit of what IPython what the IPython REPL could actually do. So the way that you start it, beta X, EIN, notebook, list, and then it asks us what port we want. I have run this on a remote server, so you can actually SSH into a remote. If you have a remote machine like on Amazon, you know, the AWS, you can run it and get it back to you. But this is just locally port 888, and then you get this list. And so the list is some untitled notebooks and one notebook, Evan 1, which you can open or whatever. And so once you open it, you get what's here. And then so the PyLab, I'm not going to live code it, but the PyLab inline allows us to have, so one of the downsides of the Emacs big statistics is if you draw a graph, you actually don't see it until you open another window, and many people have a hard time configuring the windows so that they actually show up, but particularly if your operating system is Windows rather than Linux. But you can import matplotlib. You can import this simple functions, and then actually graph it and have this information right here. IPython also has support for what's called SymPy, which is another Python library that allows us to manipulate symbols. And so you can actually do symbolic manipulation like you can in MATLAB. So you can use this language to create formulas, and then not only can you create formulas, but so that it like a latex, right? But you can actually manipulate those formulas. So in cell number 4, I say x plus y squared times x plus 1. And then, and so it can print it like it does in the output of 4. But in cell number 5, I can actually expand it, and it knows how to manipulate with those symbols to do the expansion. and it can also, do the differentiation on there in an interactive way. And it can display images and link to YouTube videos or whatever else, so that you can have a fully multimedia presentation in Emacs IPython. And so that was all I wanted to show you. And it's been very useful for me. And I will put this up on GitHub so that you can see it. So if you have any questions, I'm happy to take some. Yep.
Is it doing that those graphics there, like frame buffer? Do you have that?
I don't know. You know that org mode also has support for inline graphics. So, and Emacs also supports DTIAA, which can represent graphics within the buffer. So, those I know do it either through ImageMagick or yeah.
So like, have you ever tried running this? Can you run this without the graphics, without X Windows?
I have not tried it without an X Windows running. Yep.
This is very similar to normal IPython. The interpreter without the web thing.
Yeah.
Except that it doesn't. This has the cells that you can edit, and it's
Right.
That, like, why? Like, is there really? I haven't looked for one, but is there? Like, why hasn't someone made this just as normal IPython thing?
Oh, IPython has its own key bindings and stuff, and IPython is IPython is a joint venture between Fernando Perez, right, at Berkeley, and Brian Granger at Cal Poly. And so Granger is a VI user, and Fernando is actually an Emacs user. But they seem to be going more in the direction of VI, since it now has like IPython 2.0 has sort of a command mode, and it's like sort of modal stuff now. But I think that, the reason I really liked it was I really loved not having to learn another set of key bindings and being able to do all of the things that I can do in Emacs with text in an interactive environment. And I think that this is much more robust than the R REPL. So that was.
So how do you actually get IPython working in Emacs?
So if you're on Emacs 24, it's the package EIN for Emacs IPython Notebook. But you can, if you do package list packages.
And you have to have IPython installed separately, right?
Yes. So if I.
Is it compatible with all versions of IPython?
No. So let's. So this is, so it's EIN, installed Emacs IPython Notebook. If you're in 24, that's what you need. It only really works with the Notebook 1 through 1.21. There are some people working right now to get it to work with 2. So I don't think we're years away. I think we're weeks away from it working with 2. Because, Emacs can support, through evil mode, we can support different modes and VI would have a tougher time doing what we can do, but we can always do what they do. So.
That is cool.
All right. Any other questions? Okay. Thank you so much for your time. I really appreciate it.